Hi 213. In this video we're continuing with section 12.1 where we're talking about congruence and constructions. So we'd like to talk now about some triangle congruence because we already talked about constructing circles and line segments with the congruence, that is. So let's talk about triangles. So two figures are congruent if it's possible to fit one figure onto the other so that the matching parts coincide. And this is specifically true when we have triangles, right? We're able to say that triangle ABC is congruent to triangle A prime B prime C prime because it would be possible for us to take this triangle over here and just lay it right on top of the other one and have all of the parts match up. Remember, congruence means same shape as well as same size, right? That's important. So how do we talk about two triangles being congruent? We say that triangle ABC is congruent to triangle A prime B prime C prime, written as we just saw in the previous slide, if and only if we have the following. Angle A has to be congruent to angle A prime, angle B has to be congruent to B prime, angle C has to be congruent to C prime, AB segment has to be congruent to A prime B prime, BC congruent to B prime C prime, and AC congruent to A prime C prime, right? So really, this just means that, the angle here at C and C prime are the same, A and A prime are the same, B and B prime are the same, side AB and A prime B prime are the same. The little tick marks are showing you the congruence, right? Remember I showed you in class how we denote these congruencies with these little tick marks like this. And you can actually do this alternative tick mark here notation for the angles. I also told you an option was to label them with concentric circles, right, or concentric arcs, right, where if you say C is congruent to C prime, that's one arc, and then you could say this would be a double arc, and then this could be a triple arc right here, triple arc, to denote the congruence there. Okay? So one thing we like to say with these congruent triangles is corresponding parts of congruent triangles are congruent, abbreviated as CPCTC, right? So this is actually a theorem that they use in geometry really, really regularly because it allows you to say that parts of triangles are congruent because they are corresponding, because they're the same orientation, the same part of the triangle. So how would we write notation here to denote that these triangles are congruent? It has to be in a certain order, right? So we can't say ACB is congruent to EDF in just random ways with the letters being oriented. You have to say it in a certain way, right? So notice here that we have AC is 3, ED is 3, so that means those sides are congruent. CB is 4, DF is 4, and we have a right angle at C and a right angle at D. So that means here that we know that triangle ACB is congruent to triangle let's see, I said ACB, which would mean EDF. How do they say it? They say ABC is congruent to EFD, right? You have to orient it in the same way, right? A is congruent to E, B is congruent to F, and C is congruent to D, right? So you have to have it in the correct orientation. What about this one? So here we know this is a 60 degree and this is a 60 degree up here because this is 30 and this would be 30 then also with angles of a triangle adding up to 180 degrees. So let's see how we denote it. ABC congruent to RQP, and that's true because Q and B both have the angle of 30 degrees down here. Angle C and P both have 90, so C and P are in the same orientation, and A and R both have 60, so they're at the beginning, right? So ABC, RQP. Ways to figure out if two triangles are congruent have this fun abbreviation here. So there's a few ways to quantify whether two triangles are congruent just based on a few pieces of information. The first one of them is called side-side-side congruence condition. So if the three sides of one triangle are congruent, respectively, to the three sides of a second triangle, then the triangles have to be congruent. So if the three sides are congruent to this three sides of another triangle, then the triangles are congruent. So here in this example, we can see why we have two congruent triangles if we can use this side-side-side argument here, right, denoted as SSS, right? So notice that AB is 3 as well as ED, BC is 2 and DF is 2, and AC is 4 and EF is 4. So since we have 2, 3, 4 here, right, 2, 3, 4, we're able to say we have side-side-side congruence. Okay, and this is just the fancy notation for that, right? AB is ED and so on. Okay. Likewise for this bottom one, we can see that the sides on the outside are both 8, these are 5, and they share this side here, which means obviously BC is the same thing as BC, right? BC is congruent to BC, so triangle ABC is congruent to triangle DBC. Again, make sure it's labeled in the proper way. Okay, so how do we construct a triangle congruent to a triangle we currently have? Let's say we start out with a triangle like this and we want to construct a triangle that would be congruent to it, right? How would we go about doing this? So instead of reading through the instructions, you're more than welcome to go about watching this little part right here, right? But we also have a nice video to show us using a compass so that we actually see the complete construction. We'll stop right there for this video and we'll continue with our next 12-1 video.